Hi, Assalamualaikum. My name is Muhammad Adlaiman and my numeric is CE220106. Today I will present numerical method code BEE32403 and the title of our project is Approximation Average Solar Irradiation Data Malaysia in Kuala Lumpur. We are group 1 from section 1 and our lecturer is Dr. Rohaida binti Mat Akir. Second, this is our team group. First is me, Muhammad Adil Aiman, and my number metric is CE220106. Second is Haikal Ikmal bin Abdul Hadi. His number metric is CE220093. And lastly, Muhammad Zaki Izzat bin Osman, and his number metric is CE220075. For introduction, first project background. Our project is to utilize our understanding of the Lagrange interpolation technique and Newton divided difference method in order to establish a mathematical correlation between average solar installation data Kuala Lumpur, Malaysia. Second, to identify the rate of solar installation, we will use data obtained from the internet regarding solar installation data every month in Kuala Lumpur, Malaysia. Third is to record the rate of the number of solar installed in July. We use the Lagrange interpolation method using Newton divided difference approach. Lastly, to reinforce what has been recorded, we will use MATLAB software to model the project. This is our problem statement. As you can see, we get it from the article, and this we collect data from January and until December. Okay, and we assume the missing data in July. Uh, and approximate by using Lagrange interpolation and Newton divided difference method. Okay, the methodology is to complete the numerical method project. There are two methods used from chapter 3, especially Lagrange interpolation and Newton divided difference method. Valuable interpolation technique due to simplicity, flexibility, efficiency, and ability to handle unevenly spaced data. Based on average solar irradiation in Malaysia, especially in Kuala Lumpur, the polynomial, all the value are calculated in manual calculation and are proven from the simulation made using MATLAB. Okay, we use two methods. First, Newton divided difference, and second is Lagrange interpolation. So, Lagrange interpolation has four approximation. First, we use linear, quadratic, cubic, and quartic.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zaki Izzat bin Osman, metric number CE20005. So, for my part, I want to present about a Newton divided difference. Okay, next, we move to the method 1. We use the Newton divided difference. In this slide, show the manual calculation we do. Okay, as you can see the question, the total average solar irradiation data Malaysia Kuala Lumpur approximate the average solar irradiation data Malaysia Kuala Lumpur in the month July by using Newton divided difference. The number of months in this data and in the data is January, February, March, April, May, June, August, September, October, November, and last December. The missing data is in the month of July. Okay. The number of months is the number of x. The average solar is the function of x. If we have 11 data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We can perform Newton divided difference interpolation similarly to what we did with 10 data points. The divided difference table for 11 data points will have 11 rows and up to the 10 order difference. You will calculate each divided difference using the given 11 data points, filling in the table accordingly. After complete the table up to the 10 order difference, after complete the table up to the 10 order difference, we use this coefficient in the Newton divided difference integration formula to obtain the polynomial that fit this 11 data point. This process allows you to generate a polynomial equation that approximates the relationship between the x and y value for the given data with given data point. Okay, as you can see, the Pn, the number of order polynomial from this data is a 10, so the number of order polynomial interpolation is 11. So the quotient for approximate is a 4.83606, and the absolute error is z minus approximate, and we get 0.0139. Okay, move to the MATLAB simulation. In the first row, define month data as string month: January, February, March, April, May, June, July, August, September, October, November, December is a number of months as x. If the next row is define average solar irradiation data: average solar 4.73, 5.3, 5.35, 5.2, 5.04, 4.91, and none. Next, 4.8, 4.82, 4.71, 4.31, 4.12. Okay, the next row, target data index for July 7. Define average solar irradiation data is a function of x. Okay, next, the row target data index for July 7. Target data is 7. As you can see, we assume the month of July is a missing data. Okay, the next row, find in list of available data. After that, calculate Newton divided difference for tension, MATLAB. After that, for the result, we got a Newton divided difference coefficient. The approximate value is 4.82.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haikal Iqmal bin Abdul Hadi. Number matrix is CE220093. So I would like to explain about our method for number 2, Lagrange interpolation polynomial of degree linear approximation. So this is the manual calculation for linear approximation. So the first thing first is we need to create a table. So I 0 1. So X is represent for the month. So this is the June and this is the August. So Y for June is 4.91 and for August is 4.8. So basically this is the formula for linear approximation. So 7 is our interpolate. So 7 minus 8 x1 and divided by 6 minus 8 x0 minus x1, and we need to times 4.91, which is y0 4.91, and then we need to plus, and this is the second equation, this one, and then we need to times 4.8 y1, this one. And for the first equation, we got 2.455, and we need to plus 2.4, so the answer is 4.86. This is our approximation value. So what we need to find is absolute error for this one. So our exact value is 4.85. So we need to minus the formula for absolute error is exact value minus approximate value. So 4.85 minus 4.86, so equal to 0.01. So this is the absolute error for linear approximation. So for the MATLAB simulation, so this one is the first thing first. We need to do is we type x. We type x 6 and 8 and y 4.91 and 4.8. So the interpolate is 7 and the exact value is 4.85. So the term 1 is basically referred to this one, and the term 2 is referred to this one. So this one, 1 is actually is this one 0 and 2 is 1. So term 1 plus term 2, and then we calculate the absolute error manually. So absolute error is exact value minus approximation value. So this one, exact value minus approximation value. So we got absolute error. So for this coding is just a display manual result. So what we got here is this one. This is the final answer, same as the manual calculation here. Linear approximation, approximate average solar irradiation in July is 4.86. This one is the approximate, and the exact value is 4.85, and the absolute error is 0.01, same as the manual calculation. So next is the quadratic approximation. So for the quadratic approximation, same as the previous one, which is first we need to create a table, and then this one is I 0, 1, 2. Okay, so as usual, X is represent a month. This one for May, this one for June, and this one for August. For the Y, for the May is 5.04, and for the June is 4.91, and for the August 4.8. So this is the formula for the quadratic approximation, and this one just put in the formula all the given. And for the first equation, we got negative 1.68, and we need to plus for the second equation 4.91, and then plus for the third equation we got 1.6, so equal 4.83. So for the 4.83 is the our approximate value, and this one for the absolute error is 4.85, which is exact value, minus approximate value 4.83, so we got 0.02. So we move to the MATLAB simulation, and given the data point is X, which is month 5, 6 and 8, and Y 5.04, 4.91 for the June, and 4.8 for the August. So value interpolate as usual 7, same, and the exact value is 4.85. So for the approximation, and then we calculate the absolute error. So absolute error is absolute error exact value minus approximation value. So we got the absolute error. For the 17 line is just display the result. So we got the result here: quadratic approximation, Lagrange interpolation. Approximate average solar irradiation in July is 4.83. So which is this one, 4.83 is the approximate value, and the exact average solar irradiation in July is 4.85. So the absolute error is 0.02. So the answer we got in the MATLAB simulation exactly same with the manual calculation here. So we move to the next one, which is cubic approximation. So this is our manual calculation. First thing first, we need to create a table, and then I is 0, 1, 2 and 3. So for a month, we take April, May, June and August. For the April, 5.2, for the May 5.04, and for the June 4.91, and for the August 4.8. So basically all of this is a formula for cubic approximation, and our exact value is 7, 7 our interpolate, so which is X. So just put in the formula that are given, and then choose like a previous one. This one X, and X1 is 5, and 7X, and minus X2 is 6, and times X 7 minus X3 x3 is 8, and divided by x0 is 4, and minus x1 is 5, and then times 4 is x0, and minus 6 is x2, and then times 4 x0, and minus 8 is x3, and then times 5.2 which is y for the uh, month of April. So we need to plus for the this equation, and then plus this equation, plus this equation, same as before. And then we got the first equation is 1.3, and then plus negative 5.04, and then plus 7.365, and then plus 1.2. So is it equal to, this one is a approximation value is 4.825. So we need to find as usual, we need to find the absolute error. So exact value minus approximate value, then we find and then we got the absolute error. So 4.85 our exact value, then minus 4.825 which is our approximation value, and then we got 0.025 which is our absolute error. So we move to the MATLAB calculation simulation. So it's like before. So we just put x and y. X, the data is 4, 5, 6, and 8. So for the 4 is y for the 4 is 5.2, 5.04, 5.91, and 5.8 for the August. So our interpolate is 7, and exit value is 4.85. So and then we find the absolute error. Absolute error is exact value in July, and minus approximation value that we got. And then for this line is just a display result for the final result, and then the result in the MATLAB is approximation average solar irradiation in July is 4.8250. So which is same in the manual calculation here. And then our exact value is 4.85, which is this one. And then the absolute error is 0.025. So this one, same as a manual calculation, 0.025. So the last one is a quartic approximation. So for the manual calculation for quartic approximation, same as before, first thing first, we need to create a table, and I 0, 1, 2, 3, and 4. This one for quartic approximation. So for the month, we take March, April, May, June, and August. Y for the March is 5.35, for the April is 5.2, for the May 5.04, for the June 4.91, and for the August 4.8. So basically all of this is the formula for quartic approximation. So we have F0, F1, F2, F3, and F4. All of this we need to plus. So the first equation, this one, for quartic approximation, and we need to times 5.35, which is y0, and then this one we need to times 5.2, which is f1. This one we need to times 5.04, which is f2, and this one we need to times 4.91, which is f3, and then last one is we need to times all this equation, we need to times 4.8, which is f4. So for the first equation, we get negative 1.07 for this one. And then for the second equation, we got 5.2. And then for this one, we got negative 10.08. And for this equation, we got 9.82. And for the last equation, we got 0.96. So for our approximation value is 4.83. So what we need to do is find the absolute error. So our exact value is 4.85, and then our approximation value is 4.83. So we need to minus exact minus approximate value, and then we got our absolute error is 0.02. This one for the manual calculation. So we move to the next, which is MATLAB calculation, MATLAB simulation. So the first thing first, just insert the data, which is March, April, May, June, and August. So for the March is 5.35, for the April is 5.2, for the May is 5.04, and for the June 5.91, and for the August is 4.8. So our interpolate x is 7, same as before, and exact value is 4.85. So and then after that we need to find this one, how to get the answer. So this one, calculate the absolute error, which is exact value minus approximation value. And this code is just for the display the result. So what we got, the result is approximation average solar irradiation in July is 4.8300, which is for the manual calculation is 4.83. So which is same with the manual calculation, and our exact value is 4.85, and the absolute error is 0.02, which is exactly same with the manual calculation here.
Okay, in conclusion, the results produced from the datasheet were consistent with the information provided, the calculation performed, and the utilization of MATLAB. This amplifies how both mathematical relationship can be employed to ascertain unknown information. In summary, our research demonstrates the magnitude of the Newton partition. The Lagrange difference and interpolation method are utilized to locate and reconstruct the data.